Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. So my name is Mohd Fahmi bin Muhammad Zawawi. I'm from the Department of Electrical Engineering from Polytechnic Sultan Abdul Halim Muazzam Shah Jitra Kedah. So I'm here to present my research paper, which is titled A Study of Bluetooth Rssi for Localization and Positioning in Robot Soccer Application. So the topics that will be covered in my presentation is first, the introduction for this presentation. Second, the material that we use in experiment. And the third, the experiment itself. The fourth item is for result and discussion. Last, we conclude the presentation. So for the introduction, our research, mainly we use Bluetooth technology. The Bluetooth is a short-range communication that is simple, secure, and can be found anywhere. So why we use Bluetooth? Because Bluetooth use the technology which is robustness, using low power and low cost. The communication that used in Bluetooth will transmit and receive the frequency 1600 times per second and will be used 79 different frequencies. So the range of Bluetooth network can be 1 and up to 100 meters. So that is why we use this technology in our experiment. So the Bluetooth technology transmit both synchronous as well as asynchronous data about 24 megabyte per second at physical layer network. So why we use Bluetooth? So we have done a literature that the WLAN is more complex with large scale variation, diffraction, have a reflection, and WLAN have distortion, and also the WLAN is scattered are the main obstacle to achieve accuracy for localization. So Fisher in his research said that the indoor localization use GPS or DGPS, which is Differential Global Positioning System, does not work sufficiently for indoor localization. And consequently, for short-range propagation, Bluetooth give more accuracy in terms of localization rather than Wi-Fi. That's why we are choosing the Bluetooth technology in our research. So what is localization? So localization is the ability of the robot to locate itself within an environment. So in localization, there are two terms combined, which is positioning and orientation of a robot at any given instant of time. So means that to localize, the robot need to know its position, current position, and where are the heading of the robot, which is the orientation. So in global localization or positioning, it aims to determine the pose of the robot in a known environment, like a land map or the presence of landmark or beacon. That was found from research of Sebastian Tran in August 19, 2005. So Bluetooth localization, as you can see in this slide, so it use a reflection, means that the transmitter will reflect the data and the receiver will receive. So indoor localization by using Bluetooth using time measurement principle, where the electromagnetic wave propagation time is measured. So the transmitter will send the signal at known time and the arrival time is measured when the signal reach the base station. So determine the distance the differential of arrival scheme was proposed, as found by Gunther Fischer in his research. So means that to know the length, or to know where are the transmitting and receiving, so we can know the distance from the transmitter and the receiver. So in our research, we have used triangulation method, which is to estimate the position from the approximation of the relation between radio signal strength indicator and the associated distance between sender and receiver. So we adopt this concept and enhance it with more access point to get more accurate data. So in our research, we have 3 access point. So the access point will be put on the at the edge of the field. So Aswin, in his research, introduced the trilateration method to achieve more accuracy. So they conclude that the method can be used for robot localization in indoor environment with an accuracy of less than 1 meter using a computational inexpensive method, which is particle filter. So in Bluetooth, they use RSSI, which is receive signal strength indicator, as a parameter with 8-bit integer to show their transmitting power level and their range, as shown in table 1 below. So there are 3 types or 3 class of the Bluetooth with its power level and its range. So this Bluetooth network in indoor localization and positioning is carried out using signal parameter. So this research mainly will discuss the signal parameter for distance estimation using this RSI value. So in our experiment, we will measure the range from the robot and with the transmitter for the Bluetooth. So from the range, we can know how far the range and how the power level of the RSSI value for the robotic detection of the Bluetooth. So in Bluetooth, there are relationship between GRPR and RSSI value, which is the GRPR and RSSI value will be upper level or lower level of the GRPR, means that the value for the best RSSI and for the best GRPR must be in the middle of these two regions. So according to Bluetooth specification, a positive or negative RSSI in dB means that the RX power level is above or below the GRPR respectively, while a 0 implies that is ideal, which is the within GRPR. So this graph shown the distance approximation based on the RSSI value. So this is the result from the experiment on the relationship between RSSI and the distance, as well on localization based on RF. So in our experiment, we use a test bed. So that the test bed is we are using a Samsung Galaxy Tab with an application named Bluetooth Finder. So the application will read the RSSI value from a robot in the setup testbed. So we are using one robot, name it as MID232, as a master device with its address and range 35 cm, and the manufacturer is from the Sena technology. And we are use slave device, which is the Galaxy Tab with its address, also range 35 cm manufacturer from Samsung. So this table show the Bluetooth configuration for the robot and the Samsung Galaxy Tab. So in experimental setup, so this is our experimental testbed. So this testbed is set up within the robotic laboratory in electrical department of Polytechnic Sultan Abdul Halim Muazzam Shah. So the dimension of the laboratory are 10 multiply 35 meter with an area of 250 meter. So from the testbed, the field we divided to 20 cm of each grid, means that 180 cm multiply with 220 cm. So the total point from this testbed will be 120 point we need to measure. So by using triangulation method, we enhance to use 4 access point, which is 1 access point for each side. So for the data collection, so the robot recognition will use Bluetooth Rssi. So in data collection, we will use a robot with the physical address and we set as the sender, and also we will use the Samsung Galaxy Tab as the access point. So from the robot, the robot will be placed for each this particular point, which is total to 120 point, and the robot will be measured from the point to the access point. Let's say that from here, access point 1, so we put robot in the first quarter here, and will be measured the length, and also will be measured the RSSI value. So this step will be get the data and will be read 6 times for each point. So the distance between the robot and access point will be calculated and will be measured. So this step also will be continue same step for another access point, which is access point 2, access point 3, and access point 4. So after that, the result will be plotted in the graph. So from the experiment that we have done, so for access point 1, it shows that the strongest RSSI value at 37 dBm and the lowest at 61 dBm. So the distribution of the data as shown in this figure 1, with RSSI value mostly in range of 40 dBm to 60 dBm. Meanwhile, for access point 2, so the maximum RSSI value that we get is 48 dBm and the lowest is 63 dBm. So the overall range of the RSSI value for access point 2 is between the range of 40 dBm to 60 dBm. Meanwhile, only minor place in the graph with RSSI value over 60 to 80 dBm. So for access point number 3, the maximum RSSI value that we get is 39 dBm and the lowest at the 59 dBm. So the results show that there was some fluctuation in the value of the RSI in the some place in range of 50 dBm to 60 dBm. But in most area, the range is 40 dBm to 50 dBm. So from this, we know that the closer the distance from the transmitter will resulting the RSI value to decrease, means that the signal is high. For the access point number 4, the maximum RSI value at 43 dBm and the lowest at 59 dBm. The result shows that the distribution of the RSI value were recorded at the range of 40 dBm to 60 dBm only. So for the conclusion, we presented in this paper to propose robot soccer localization using Bluetooth RSSI. So we choose to use Bluetooth RSSI rather than other wireless technology because of its ubiquitous and easy to communicate the data. And also the Bluetooth have low power consumption compared to Wi-Fi, and also it use less interference when the number of devices is high compared to Wi-Fi. For the future work, our research aim is to improve the data, to use analysis using support vector machine, and to propose a niche model to get accurate localization for robot soccer using Bluetooth RSSI. This is all the reference. So that's all. Thank you for having me.